We are now looking at the laws of exponents, and in general terms the four basic laws that we will encounter when working with exponents. Now you should be familiar with the following algebraic techniques, where if we say m to the power of 5, it literally means m times m times m times m times m 5 times, multiplied with itself 5 times. Same goes for the next line, where we have a bracket to the power of 3. It's whatever is inside the bracket, 2a squared, multiplied by itself 3 times, and then we multiply the numbers. 2 times 2 times 2 is 8, and in total there are 6 a's that we can work with. Next line, we've got the 2 outside the bracket, still a squared inside the bracket with a 3, so it is a squared, a squared, a squared, multiplied with itself 3 times, and then we have the 2 in front, which will then give us 2a to the power of 6. The next line, you've got to be very careful. We actually say to you there, you should do the exponent of the bracket first before you multiply with the minus in front. So we'll look at that to the power of 4 first, which literally means minus 1 times minus 1 times minus 1 times minus 1. And a minus times a minus is a plus, multiplied by a minus again is again a minus, and multiplied again by a minus will give us a plus 1 that we have there, multiplied with the minus in front will give us minus 1 as the answer. And the same goes for the next one, but this time around we have an odd number in the exponent. So now it will be minus 1 times minus 1 times minus 1. Since it is an odd number, we will get minus 1. Not like the plus 1 that we did before, multiplied with the minus in front. Now we have a minus times a minus is a plus 1. Now these are the fundamentals of working with exponents, but you should also learn the laws that govern operations with exponents, and that's what we'll be looking at now. Law 1 says a to the power of m times by a to the power of n is equal to a to the power of m plus n. In other words, if you multiply two numbers and they have the same basis, as in this case the a, you'll just add the exponents. For instance, y to the power of 3 times by y to the power of 5 will give us y to the power of 3 plus 5, or y to the power of 8. Law 2 is just the opposite of that, where you divide. Now you'll subtract the exponents. So m to the power of 7 divided by m to the power of 3 will give us m to the power of 7 minus 3 is equal to m to the power of 4. 7 minus 3 is 4, and this could also have been written as m to the power of 7 over m to the power of 3. Means exactly the same as division. Law 3 says if you have a bracket with an exponent outside the bracket, you can simply multiply those two with each other, and you'll get a to the power of m times by n. So looking at an example, inside the bracket, m to the power of 6, outside the bracket to the power of 3, this will give us m to the power of 6 times 3, or simply m to the power of 18. And then law 4 is very much the same as law 3, except now we could have more terms inside the bracket. In law 3, we only looked at one term, a to the power of m. Now we have, with law 4, ab to the power of m. The bracket is to the power of m, but there are two terms inside the bracket, and since each of them will be a to the power of 1, b to the power of 1, we'll multiply both of those terms with the m outside, and we'll get a to the power of m, b to the power of m. The same happens if we divide inside the bracket. Again, that is a to the power of 1, b to the power of 1. So we'll multiply both of them with the exponent outside the bracket to give us a to the power of m over b to the power of m. And just to look at some examples, if we have 4a inside the bracket to the power of 3, that will give us 4 to the power of 3, a to the power of 3. Remember, if there are no exponents, you can assume it is a 1, and that will then give us 64a to the power of 3, because 4 to the power of 3 is 4 times 4 times 4. That's 64a cubed. Then looking at the division inside the bracket, we'll get 4 to the power of 3 divided by a to the power of 3, or alternatively 64 over a to the power of 3. And then just the other way around, looking at it from a different perspective. If you have two terms multiplied with each other, the 2 and the 5, and both of them have exactly the same exponent, you could group those two terms, the 2 and the 5, together in a bracket with the exponent that was common to both of them before, and that will then give us 2 times 5, or 10 to the power of m. And then lastly, again looking at a fraction where you've got 8 to the power of 3 over 2 to the power of 3. Look at the fact that both of them have the same exponent. You could group them together. 8 over 2 inside a bracket first, 2 to the power of 3, and 8 divided by 2 is 4. And 4 to the power of 3, as we said before, is 64. So those are the 4 laws. All possible definitions of exponents will flow from these basic laws. If you look at the original examples that we did, you'll notice that one we got the 5 by adding 1 and 1 and 1 and 1 and 1, the first exponential law. That one is the fourth exponential law. We multiplied 2 to the power of 1 with the 3 outside, that gave us 2 to the power of 3 or 8, and we multiplied the a squared with the 3 outside, that gave us a to the power of 6. Same goes for that one, also the fourth law, same goes for that one, same goes for that one. Except you've got to remember the terms outside the brackets and so forth. Order of operations, brackets always first before everything else. But apart from the basic arithmetic rules, the laws of exponents as we've just done them, the 4 basic laws, is all you need to understand everything in exponents. You just need to practice and become familiar with the variations of how they are being asked in different questions.